slavery is real. Doesn't mean the shackles gotta be revealed. Fighting with my pen, it's the closest thing to steal, and it's what they wanna steal. There's value in the word, gotta figure out the real. We're juggling and wrestling thoughts in my mind. The influence was heavy, are the thoughts even mine? Label still persuading like I'm needing a dime. Like my people ain't be dying over gold in the mines. It's funny, right? I'm still numb to the trauma. I couldn't tell if my joy was out of love or what would haunt me when I needed me a hug. That's the realest. Yeah, it's the closest thing to feeling. Yeah, it's the only thing revealing. Trying to get me closer to the Lord, cause maybe he can open up some doors. While these words get to show you all my flaws. It's poetry and pain, blessing in the chain, pictures I could paint. Yeah, it's poetry and pain, blessings in the chain, pictures I could paint. Yeah, it's poetry and pain, blessing in the chain, pictures I could paint. Yeah, it's poetry and pain, blessings in the chain, pictures I could paint.
Now I've been calling, been stalling, been falling, we go again. Timing so precious, a blessing, don't mess it up all again. Money, it come and it go and it come and it go again. Loving is true, it don't go here to stay, we go again.
Yeah, so thank you for having me here at You Got This. This has been, the talks that I've watched since I've been awake have been fantastic, and I hope you've all really enjoyed them. My name is Steve. I say it as Steve. I write it as Steven. That's kind of irritating. I'm sorry. That's just how it is. But on the screen, you can see my contact info on Twitter. That's probably the best place to reach me, at P. Popowitz. and my email, steven.j.hicks@gmail.com. Also, all of the slides that we're looking at today are available on the internet. They're at that URL, stephenhicks.me/getting-unstuck. As Nathaniel mentioned, I am an engineer at Artsy. Artsy is a company based in New York where we're building a platform for collecting and discovering. Milwaukee in the United States is kind of the Midwest part, a couple hours north of Chicago by car. So I'm going to ask a couple of survey questions to kick us off here real quick. We're going to come back to this in a little bit, but the two things that I want to know from you are, if you're able to answer these questions, what is your experience level in your career? Beginner, intermediate, advanced. If you prefer to think of that as junior, mid-level, and senior, that's fine. Think of it that way. And then the second question, have you gotten stuck on a problem recently? Yes or no? So we'll circle back to this in a little bit. Maybe helpful is to define what we are, what I mean by the word stuck, right? It's kind of nebulous. It's a little bit unclear. So to add a little bit of clarity to this, what I mean when I say stuck is when you've been looking at code for minutes or hours or days and you swear it should be working and you've gone over it a bunch of times and you can't figure out why it's not doing what you think it should be doing, or you've been looking at it and it's doing something that it shouldn't be doing and you're just starting to get frustrated. Now, I do a lot of different things at Artsy. I work with JavaScript and React and Ruby and Rails and SQL and Elasticsearch and all sorts of different things. And like Nathaniel mentioned, I like to say that I specialize as a generalist. But the one thing I love to do, regardless of tooling, is to help people get unstuck. And I've got a lot of really great teammates who are good at getting people unstuck too. So I've taken some notes on how we help get each other unstuck, and that's really what I want to share with you here today. And the first thing I have is maybe a little bit of less of a strategy and more of a mindset shift, right? So we're going to embrace the stuck. Jumping back to that survey question, those survey questions that I asked, what's your experience level in your career, and have you gotten stuck on a problem recently? And I am not seeing any responses to this anywhere. I wonder if I have to look somewhere else. But basically, what we tend to find here is it's not just beginners that get stuck here. It's everybody that gets stuck. So especially you beginners. Okay, now I'm seeing the responses. So let's go take a look. What do we got? Intermediate, yes. Intermediate, yes. Yeah, so what we generally find here is everybody answers this problem yes. Even the advanced engineers, the people who've been doing this for a long time. So beginners, I want you to take note. If you're new to this job and you think that eventually I'm going to be so good at engineering and developing that I'm never going to get stuck, that's not the case. That day is never coming. You keep getting stuck, the problems just become different. I have a former coworker and a friend named Will who wrote an article that he called to start meditating, stop trying to empty your mind. And in that article, he talks about how many newcomers to meditation think that they're bad at it because their mind isn't empty and their mind wanders and they think about a lot of different things. Will makes the point that having an empty mind is not what meditation is about, especially for a beginner. It's about mindfulness and noticing that your mind is wandering, and that's really it. In his article, he says, it may feel frustrating and like you're doing it wrong, but that is the practice. Similarly, when it comes to getting stuck as a developer, getting stuck is not a reflection of your skill level. It's not a reflection of your experience level. It's not an impediment that's preventing you from doing your job. In fact, getting stuck is the job. It's what we're getting paid to do. We get paid to get stuck and then get unstuck. It's our unique skill, and it's why we get to do this instead of someone else. And it's okay to be stuck because that is you doing your job, which is not just to write lines of code, but also to solve problems. And honestly, it takes time to solve problems. It's okay if it takes you a while to get through something. So with that mindset shift, let's look at some more actionable strategies for you. The first set of strategies I have are in regards to explaining the problem. You run it, you get stuck on something, find a way to try to explain the problem to someone or something. And let's talk about some of those strategies. You can write about it. Lots of different places to write about your problem, about why you're stuck. maybe you're old school and want to write an email to somebody who you used to work with, or a Slack message to a teammate. Maybe you like to ask questions on Stack Overflow, or you have a blog that you like to write on. I keep a work journal. This is a really nice thing because I keep track. I write about the problems I'm running into, and then I can go back in time. And when I run into that problem again 3 months later, I remember what I was stuck on and do a quick search, and I can find how I got through it 3 months earlier. Maybe you've got a dependency that you think there really is an issue with it. Go ahead and start writing up a GitHub issue. Well, the last one on this list I really want to call out as something that has been tremendously helpful for us at Artsy. In our Slack, we have a channel named Dev Help, where developers go when they're stuck on something, and they just post a question, and people come in and help answer their question and get them unstuck. And then when they've figured out the problem and move beyond it, they make sure that it's captured there in the thread and mark it with a check mark that it's been solved. The cool thing about all these write strategies is that often you don't even need to send the message. Just writing it up can be enough to help you figure out what your problem is. Maybe you're more of a verbal person. In this case, talking to the duck is a thing that you can do. Talking to the duck is an expression that comes from the pragmatic programmer, where basically you have this little duck, rubber duck, that you keep at your desk. And when you get stuck on something, you try to explain to the duck what's going on. It does not have to be a duck. It doesn't have to even be a real thing. It can be real or it can be imaginary, but it's definitely most effective. The strategy is most effective when you are talking out loud. You have to explain the problem to the duck out loud. Say the words out loud. Tell the duck what this line of code is doing. Tell where it goes next. Tell what happened, what is supposed to be happening that is not happening. If you feel weird talking to inanimate objects, you can talk to a person. Same thing as talking to a duck, except it's your coworkers are the duck, basically. If you're lucky enough to be in person with some coworkers, ask them to look over your shoulder. For most of us, we're working virtually, and it's not too far away to just reach out over Slack or Teams or whatever you're using and say, hey, can you take a look at this with me and let me just run some ideas off you and see if I can figure out why this isn't working. Maybe a little bit further with this, the distinction I have here in my head is pairing versus talking to a person is more like we're both going to get our hands on the code together. We do pair a good amount at Artsy. Not all the time, because that can certainly be overwhelming for people, but I like a couple hours a day, and especially when I'm stuck on a problem, reaching out to somebody and saying, hey, I'm going to start up this live share session, or let's go ahead and pair on this and see if we can trace down why it's not doing what it's supposed to be doing. So all of these things that have to do with explaining can be explained by something in psychology called the protege effect. The protege effect is something that you've probably experienced if you've ever taught someone something through a one-on-one or a lunch and learn or a workshop or just teaching newer employees, or even if you've written a blog post about a topic and you find yourself researching it deeply so that you understand it enough to write the blog post. If you've done any of those things, you've probably experienced the protege effect, which is that when you teach something, you tend to learn it more deeply. Now, we're not teaching someone a skill when we're explaining why we're stuck, but we're teaching them our mental model of the problem space. So this can give you a better understanding of your model of the problem space. A couple of things happen when you are teaching something to someone. You're inspired to think about or to learn the topic thoroughly because you're going to have to explain it and you don't want to look like a fool. So you actually use better learning strategies, which is really cool. And it also inspires you to think about how you would learn the topic. You do a little bit of meta thinking here. While you're learning, you're thinking about how you would learn it if you were to go back and do it again, or how you might teach it to someone else, how they might best learn it. There are a few studies that have been done about the protege effect, and I'm going to highlight one here from 2016. The name of the study is there at the bottom in blue. In this experiment, the control group was told, hey, here are some things, you're going to learn them. The experiment group was told, hey, here are some things, you're going to learn them. And when you're done, you're going to go teach them to someone else. And what the researchers found was that the students in the learning by preparing to teach intervention developed a more detailed and better organized concept map of the problem. They learned it better, basically. I'm going to zoom in on these words, learning by preparing to teach. That's an interesting name to give this experiment group. What it's pointing out is that this group that was told that they were going to teach something to someone else after they learned never actually went to teach. It was just the act of thinking that they were going to learn it. It gave them, or they were going to teach it. It prompted them to start using those deeper learning strategies to understand this problem better. The other thing that happens when we explain something to someone is that it forces us to challenge our assumptions and prove that the code that we think is running is actually running. I think this is really critical and important for all of these strategies, this challenging of assumptions. And it kind of reminds me of some other things that I've read or experienced. There's a book by a psychologist named Csikszentmihalyi, and if you're familiar with the concept of flow, that comes from this book. In this book, Mihai talks about creativity and flow, but I just want to pick out this one quote because I think it's really interesting and related to challenging assumptions. He says, "Experience this one thing for what it is, not what you think it is." And this is pretty similar to what I remember being taught in art class when I was a younger student, when I was in grade school and then college. And I also see my kids learning this about their art too. I don't know how many times teachers told me, draw what you see, not what you think you see. You often you think you see something that isn't there, or you're simplifying it. And this is about symbols, right? When we see this drawing right here, we recognize it instantly as an eye, but it's not an eye. It's three simple shapes. That's not really what an eye looks like. It's a symbol of an eye. And our brain is able to use this as a shortcut to say, oh, okay, so we're talking about eyes now. In reality, an eye looks more like this, right? It's got incredible detail and subtlety, and there's a lot of colors in the iris. Those are blue eyes for sure, but it's got green and brown and gray in there. And you can see a reflection of the lashes, and there's that bloody, pulpy thing in the corner that I'm sure has a name, but I don't know what it is. When we are focused on a problem in our code, we use symbols like this. We make assumptions. We build up a model in our head of all the pieces that are working together, and we treat them as black boxes and abstractions. So maybe there's 4 different things that are interacting together in our code here. We don't look at the details of each of them. We think of them more abstractly and about how they interact that way. But they're symbols, and you just assume that they're working as you think that they work. When in reality, every one of those abstractions has incredible complexity and detail. So much complexity that we have to treat them as these abstractions, because if we didn't, if we tried to understand every single line of the entire system, it would just be overwhelming. There's way too much going on, too many details. And when you get stuck, it often means that our symbols don't reflect the reality of what's going on in the code. So those abstractions are a little bit different. Those black boxes are differently shaped than what they really are in the code. And explaining the problem forces you to evaluate every assumption and every one of those shapes and explore the details of each of them. And that is often when you uncover the issue. Next, we're going to figure out how to isolate our problem when we get stuck. I've got a few strategies here, and it starts with some risk analysis. We're going to ask ourselves a few questions. What's the thing I have introduced to my code that I know the least about? What is the thing most likely for me to improperly use? These could be dependencies, they could be new code, they can be existing code. And finally, what is the thing I'm making the most assumptions about? I'm just really getting more directly to the point here. If you can give a solid answer to any one of these questions, there is a good chance that that's where you're stuck, and you should head that direction next. Even if you can't, a good strategy to start with for isolation is removing code. And we can do this by deleting code a little bit at a time. So maybe I have several blocks of code that I know overall they don't do what they're supposed to do, and I'm not really sure which one is failing me here. Just remove some of it. Stick in a hard-coded line that returns something that function that you're expecting that function to return. And now we have a smaller problem here. Maybe we can go even further and remove more code and just keep removing these little bits, a little bit at a time, so that eventually we're dealing with 10 lines of code instead of 50, 100, 200 lines of code. And maybe this will help us isolate with this smaller block of focus. We can apply this to our recent changes too, if we're using something like Git to track our source. Instead of deleting code, now we're just backing changes out one at a time. So back out a commit, then the next commit, then the next commit, until we get to the point that the code works again. I'll point out there is actually a command built into Git that does this, or something similar to this named bisect. If we think of our system as this super sweet Lego camper here, and something in it isn't working right, these strategies of code removal are kind of like this. We're disassembling it, and we're taking it apart, and we're trying to figure out, does this raft component work with the sleep component over here? Sometimes we're not even sure we have the right pieces to build the camper, though. And we're not even sure if like that raft is going to play nicely with the wheel and the windshield. What effect is that going to have? And maybe the reason that we're stuck in this code that we're stuck on is because these dependencies are completely incompatible with each other. And in those cases, it is useful to isolate the problem by building a proof of concept that these things can play nicely together. Demonstrate the problem or the subsystem in a very isolated context, with no dependencies or nothing flashy, nothing that isn't needed to prove that these things can work together. And sometimes we get stuck because we don't even know where to start. We get stuck in kind of a state of analysis paralysis. And we know we need to build this thing, but there's all this complexity. And when we start trying to build it, we get lost in thought. And a proof of concept can help in there too, but not necessarily if we don't know what concepts to prove. And when we're at that point where we don't even know where to start, we don't know what to prove out, my strategy that I recommend is to eat the frog. Eating the frog is it's a phrase that the internet tells me comes from Mark Twain. I have no reason not to believe it, but it's the internet. Mark Twain may have said, "Eat a live frog first thing in the morning, and nothing worse will happen to you the rest of the day." A slightly more morbid twist on that is nothing worse will happen to either of you the rest of the day. But when we're faced with building a system with a bunch of pieces and we don't know which of these 4 things to start with, we just know we have to build this app, and we don't really know which ones are important for our proof of concept, choose the scariest one. Find the most risky, the one that you have the most uncertainty about, and start there. It may be that those other 3 things, whether that's like Rails in the top left and your UI in the top right and your database in the bottom right, maybe it's just like the React that you have a problem with. Start with just React as the part that you need to isolate. You can throw away the code after you do this little proof of concept, but it'll get you moving, and it'll teach you things about your system and about how things are eventually going to come together. And if that hardest problem still seems too big, think about it as multiple problems and try to separate them and approach them one at a time, starting again with the scariest and the one with the most uncertainty. Writing tests is another neat way to isolate the source if you're stuck in your code. It's an extremely useful skill for solving problems as a developer. It allows you to tighten your development feedback loop of making changes and then observing their effects and repeating that cycle. And the basic idea here with writing tests is, whether it's a unit tests of a tree of function calls or integration tests of a tree of components or end-to-end tests of a running app, if we write a failing test at the highest level that we can, we know it's going to fail because the code's not doing what we expect it to do. And then we just iteratively climb down the tree to a more isolated and granular level. And if it still fails there, we dig one level deeper. And eventually we'll get to a point where we're down to 1 or 2 blocks there where, okay, I know everything else is fine. It's this specific piece that is causing the issue. And we can figure out why our Lego camper isn't fitting together well. The common thread for all of these isolation strategies is breaking down problems. When you break a problem down from something large to something small, it gets a smaller surface area and it becomes easier to figure out. My favorite strategy or set of strategies is about escaping the problem. This starts with relaxing, taking a shower, taking a nap. When you relax and you walk away from a problem, your brain kind of shuts off about it and you let it wander. Other parts of your brain activate and they can actually find solutions without you trying. I actually read an article today that suggested this exact strategy for when you're stuck on your Wordle. If anyone has been playing Wordle, which I have, I Wordled in 4 today. You also become more open-minded to the problem and less likely to dismiss ideas that don't seem obviously related. So relaxation is just a good way to be creative. This is why we have all these ideas in the shower, because we just shut off the problem and let our brain do other things. Physical exercise is another great way to escape a problem and let your brain process it. This will increase blood flow to your brain, improve your executive functions. It'll improve your mood, which often can give you the push that you need to get back at solving the problem. And if you find something that's rhythmic and repetitive, your mind can just shut off and wander. It's great. Maybe you have other hobbies that you use to do this kind of thing, playing guitar, drawing. Any of these things are a great solution when you're stuck. And if all of that kind of feels like it's unproductive, you can choose a more productive escape strategy, like move on to another problem. If you're working on something big and heavy and deep, and you've got some things in the backlog that are just like copy changes, tackle a couple of those. You'll get away from the problem that you were working on, and also accomplish a couple things. Why does escape help us solve problems? 3 things. First of all, escaping can boost your confidence. Like I said, your mood improves from getting away from this problem that's just bothering you and you can't let go of. I do this in rock climbing a little bit. If I lose confidence working on a hard route in rock climbing, I'm ready to give up. I'll just like look around the gym for something really easy and do a couple of those, and now I feel a little bit better about myself. Like, yeah, I'm not awful at this. I can do this. I just need to try again. Also, when we come back to the original problem after escaping, we have to relearn it a little bit. And this can help you challenge your assumptions. It's like talking to the duck. And it's also kind of a nice way to rebuild your mental model of the problem. If the last time we rebuilt it, we got some of those symbols and abstractions wrong, rebuilding it might give us a chance to get them right this time. Finally, your brain can come up with the answer while you're thinking about other things, which is magical. And there are a couple of psychological principles involved here. For starters, there is something called analogical problem solving, which is where we use information from one domain to help us solve a problem in another. It happens when you notice parallels between 2 really different activities, and then you start to notice more parallels between them and more, and eventually you start reframing the original problem in the context of this second area, and it can help you overcome that source of wherever you were stuck. And then there's another thing in psychology called incubation. Incubation comes from, again, Mihai Csikszentmihalyi, his book about creativity and flow. He proposed these 5 stages of creativity based on some previously proposed stages by a political scientist named Graham Wallace. Mihai describes these stages as: preparation is when you investigate a problem consciously in many different directions. And then incubation, step 2, you kind of put the problem away. You do nothing, or you do a different problem, and your brain processes it subconsciously. Illumination is when the preparation and the incubation come together and we have this sudden insight. Evaluation, we kind of vet the idea, look at it critically. And then in elaboration, we expand on those new ideas and test them and refine them and figure out how we can best apply those ideas. He was very, very clear about the fact that there's no sequence to this. They play together in all sorts of different orders. But he describes incubation as when ideas churn around below the threshold of consciousness. It is during this time that unusual connections are likely to be made. He says, when we intend to solve a problem consciously, we process information in a linear, logical fashion. But when ideas call to each other on their own without our leading them down a straight and narrow path, unexpected combinations may come into being. The emphasis here on words like unusual and unexpected is mine. He goes on to compare this to parallel computing, which is kind of right in our wheelhouse as developers. When we're consciously thinking about a problem, we push it in a linear direction, straightforward. We're going to solve this thing, A to B. But when we set it aside and let it incubate, it expands to parallel processing, and this allows our brain a freedom to its problem solving. We can now combine things in ways that our conscious mind would have rejected. Often when we are faced with a difficult problem, we think that we need to really focus on it. And if we aren't focused on it, we're procrastinating. But the truth is, for these really complicated problems where we're really stuck, your brain and your creativity need to expand in many directions to find a solution. So staying actively focused is kind of a detriment. But if you give your brain this room to explore the space on its own time, that can help you explore these ideas that your focused, rational mind would initially reject. So go for a walk or work out, set the problem aside, take a shower, take a nap, read a book, get in the basement, do some woodworking, knit, go for a bike ride. Just let your brain kind of handle this one on its own while you do something else. Final set of strategies is about hardening yourself for the next time. Keep in mind our mindset shift from earlier. Getting stuck is the job. It's what we're here to do. Learn new ways to solve problems so that you have different tools for the next time you run into this. You can pair even when you're not stuck. There's kind of especially in my experience, people tend to think of pairing as a thing that you only do when you get stuck. But there's so much to learn from someone else when you're writing a new feature from scratch and you can see how they approach a problem and how they solve it. It's just really neat. It's a great way to learn all these different new tools. You can, GitHub is great. You can go find so many other projects to read code. You can explore new technologies, learn for the sake of learning. I keep a Trello board that I fill with messages of appreciation and thanks, and I call it my wall of motivation. There's a talk in the You Got This library by Gargi Sharma about making your work visible. She mentions Julia Evans's idea of the brag doc. That's pretty much the same thing here. This is just all of the nice things that happen and the accomplishments that I have. I track them here. But more important than tracking them is going back to look at them now and then. Because if you're like me, when you get stuck on something, your self-talk changes for the worse and you start doubting yourself and you start saying awful things. Imposter syndrome kicks in. But this wall of motivation, when I go back to it, it replenishes my ego, and it can help you remember, as long as you look at it, that you are in fact doing a great job, especially if you're getting stuck. That's your job. That's great. You're doing fantastic. It doesn't always feel like it, but this work is hard and it takes time. Keep a list of things you do every day in a journal. Like I said, I like to get a little bit deeper about trying to write about the problems I'm solving. But even just tracking the accomplishments you have, whether it's something big like shipping a feature or something small like something you learned or something you discovered or a mistake you made, small steps forward. You can look back at this journal and see that you're doing this job of solving problems. Not the first time we've talked about exercise, not the first time you've heard exercise today. Again, it reduces anxiety, depression. I mentioned rock climbing earlier. If that's within your physical means, that's a fantastic form of exercise, especially for developers, because it's all focused on solving individual problems. But whatever is accessible for you here, whatever form of exercise, whether it's just going for a walk, anything that gets the blood flowing through your body is super helpful. Meditation can also be useful. There are mental and physical benefits to meditation, especially for me, leveling your emotions, which factor into me getting stuck, like I said. That's really helpful, and it increases your ability to persist through these challenges. Get outside of your head if you can. If you can do more active one-on-ones with your leader, or if it's not your leader, someone else that you feel psychologically safe around, someone that you can be vulnerable with, and you can talk about the times that you have felt stuck, and they can talk about the times that they have felt stuck, and you can share in these struggles together. The common thread for these hardening strategies is it's about getting in the reps, conditioning yourself, strengthening yourself. We're not professional athletes. Some of us probably are. I'm not. But professional athletes condition themselves every day for these incredible physical challenges that they face. We're facing incredible mental challenges every day. We should condition ourselves for those too. All right. Summary of the things that we talked about. My strategy groups: embrace getting stuck. Getting stuck and getting unstuck is the job. Explain things to someone else. It'll help you challenge assumptions and rebuild the model in your head and figure out why you may be stuck on something. Try to break the problem down, isolate it, give yourself a smaller surface area to focus on. Set it aside, walk away, go for a run, take a shower, take a nap. Let your brain process this thing on its own. And finally, condition yourself for the next time that you're going to run into this, because you are going to get stuck again, and that's okay, and that's you doing your job. I just want to thank you all for your time. There are mental and physical benefits to meditation, especially for me, leveling your emotions, which factor into me getting stuck, like I said. That's really helpful, and it increases your ability to persist through these challenges. Get outside of your head if you can. If you can do more active one-on-ones with your leader, or if it's not your leader, someone else that you feel psychologically safe around, someone that you can be vulnerable with, and you can talk about the times that you have felt stuck, and they can talk about the times that they have felt stuck, and you can share in these struggles together. The common thread for these hardening strategies is it's about getting in the reps, conditioning yourself, strengthening yourself. We're not professional athletes. Some of us probably are. I'm not. But professional athletes condition themselves every day for these incredible physical challenges that they face. We're facing incredible mental challenges every day. We should condition ourselves for those too. All right. Summary of the things that we talked about. My strategy groups: embrace getting stuck. Getting stuck and getting unstuck is the job. Explain things to someone else. It'll help you challenge assumptions and rebuild the model in your head and figure out why you may be stuck on something. Try to break the problem down, isolate it, give yourself a smaller surface area to focus on. Set it aside, walk away, go for a run, take a shower, take a nap. Let your brain process this thing on its own. And finally, condition yourself for the next time that you're going to run into this, because you are going to get stuck again, and that's okay, and that's you doing your job. I just want to thank you all for your time.
What is going
When your business is on the path to AI, Dell AI Factory with NVIDIA can quickly implement the AI you need, help keep your data secure, and give you the flexibility to keep moving forward.
दादू रुकना नहीं है बज्जो भागो
Be someone's we from wherever you may be, as we're adding 100 stars every hour.
What is going on, fellow game developers? My name is MediWolf, and today we are continuing our 2D Endless Runner tutorial. In this episode, we are going to be actually setting up a spawner to spawn enemies that will kill our player. In the last one, we added player movements. We can jump and crouch over bullets or enemies or obstacles, whatever we're going to be summoning in. I think we're going to do some like spikes and stuff like that. So they are going to be all the obstacles we come across, and yeah, let's actually get started. So the first thing we want to do is actually create some obstacles. Now we're just going to create our first basic obstacle, and this is just going to be called a spike obstacle. We're just going to reset transform for now, and then inside of here we're going to create a 2D sprite triangle. You can add your own sprites here, whatever you want, but I'm going to just stick with a simple triangle, which will just be our spike. And we'll make this some sort of red color. That'll do for now. We can tweak all of the colors and stuff later on. Then I want to get our obstacle and actually place in, let's say, a small triangle, because what we want to do is we want to align our inner triangle with this. So what I'm going to do is I'm just going to bring this up here. I think this is fine. This will make it so if we put this let's say -4 or -3 point, oh, that's the wrong one saying that, the spike at -4, you'll see it actually sits pretty flush with the ground. Obviously it's slightly overlapping, but that's good. That means we won't see any textures, and this will be coming in like this, like as you're moving, this is coming towards you. And what we want to do is we want to make sure all our obstacles, the base of them will always sit in line with these ones, meaning we can spawn the obstacles, and let's say we wanted a spike slightly up, we could actually have it up here. So obviously it wouldn't be a spike, it'd probably be a bullet or something like that, but it could be up here, and that way the origin is what we'll move left and right, and it will keep the element where we want it on the screen. So with this, what we want to do is add in a polygon collider 2D to our triangle, just to give us that spike shape for our actual collider. We then want to go to the spike obstacle, and we're going to add a rigid a rigid body 2D that's going to be set to kinematic. This is just because we don't need to move it other than inside of a script. We're also going to freeze its rotation because the spikes don't need to rotate, and same with its Y because it will not be moving up and down, just left and right. We'll also set its collision detection to continuous. Finally, we want to create a new tag called obstacle, and then once you've got a new tag called obstacle, come back to the spikes and apply the obstacle tag to both your elements. You can also add a layer. It's not necessarily required, but I like to have a layer for different things as well, especially obstacles. Finally, I'm just going to tweak this spike to be a bit smaller. I think currently it's a little bit too big, so I'm going to just get its size and put it something like 0.75, and then I'll move this down to fit something like 0.2. Now there you go, that's what our spike object looks like. Now what I'm going to do is I'm going to create a prefab out of this by dragging it and dropping it down here. Now we can spawn as many of these as we like. Obviously we'll use a spawner for this, but it's good. I also want to create one more, so I'm going to duplicate the obstacle. I'm just going to delete the previous one. I'm just going to unpack it from being a prefab. So this one is no longer a prefab. Now I'm going to call this the spike row obstacle, and all I'm going to do is I'm going to get the spike and I'm going to duplicate it a couple of times. Let's actually do it like that. There you go. So now we actually have a row of spikes as well. It's a slightly bigger and harder obstacle, and we can spawn each one. Finally, we're going to just get a flying obstacle as well that will hit basically a screen. So let's just get a default obstacle. We can remove this because now we have a reference. Unpack this one completely and just call this the, let's say, projectile obstacle, and this will be the projectile. And what we want to do with this one is just put this back at -4 so it's on the ground. So our X position to say 0 because I want it to be close to the player so we can measure up. And then let's put the actual projectile for this slightly higher. Let's say something like, do something like 1 or even 0.5, and then let's rotate the set 90 degrees so the triangle is facing forward, and I kind of want this a bit smaller, so 0.5. Let's move this up to 1. There you go. So now you can either duck or jump over this obstacle depending on what you want to do, and let's just make it look slightly different by making it a bit more of a yellowy color. And there you go. If we look again, that's what it'll look like when it comes at you. And there you go. Now this will also just move like this. So all we'll do is move this left and right, and you'll see it can hit the player there. So let's just drag this in there. And these are the 3 obstacles we're going to start with. However, we can add as many as we want with the system we're going to create. So let's just remove this from our scene. The next thing we want to do is actually create our spawner. I'm just going to reset its transform and give it something like a little red dot there. We then want to move this to a bit further out, somewhere like this, because this is where we're going to actually spawn each obstacle. So the triangle we set up here will always match this triangle, which means it will always be running along the ground. That means for the projectile ones, which are slightly higher, this will still be there and it will still be where we want it to be. It means we don't need to create 3 different points for our obstacles to spawn out. We can actually have them random at any point we want, and we don't have to keep making new spawn locations. Now on our spawner, we are actually going to create a spawner script and just create an ad. Now opening up our spawner script in Visual Studio Code, we're just going to remove all the base stuff we don't need, and we are going to start off with setting up a serialized private game object array, which we are going to be calling our obstacle prefabs. We then need a public float, which we are going to call our obstacle spawn timer or time, which we're going to set to a default of about 2 seconds, 2f. We'll then need a private flow, which is going to be called time until obstacle spawn, and this will just be left at default. We then want to go into an update function, and we just want to create our spawn loop script. Now in here we're going to have a private void spawn loop, which will run all our spawn code in here. So what we want to do is we just want to say our time until obstacle spawn is plus equal to time dot delta time. This will slowly increment this time up until we hit our 2-second mark. We can then say if time until object spawn is greater than or equal to our obstacle spawn time, we can spawn an enemy or an obstacle. So let's create that new void called spawn and leave it here. Now later on we're going to be adding an if statement to this, which just checks if the game is still running and making sure the player hasn't died, and if the player has died then we're just going to stop calling this function. We also, inside of here, need to set our time until obstacle spawn back to 0 once we've spawned an object, otherwise it will just keep spawning objects infinitely. Now in spawn, this is where we get some fun. First off, we want to select the actual obstacle prefab. So what we want to say is a game object dot obstacle to spawn, name this obstacle prefabs. And then in here, we're just going to say random.range between 0 and obstacle prefabs dot length. Now that will spawn that will give us a random obstacle that we can spawn each time. We want to create a new game object called spawned obstacle. And we want to set this equal to our instantiate method, which will just create the new obstacle. We want to say our obstacle to spawn. So we just then want to give our transform.position of our current spawner object, and then we want it to have a quaternion.identity. This just means it will spawn it at the rotation the prefab is set at, which will basically give it its own rotation. So if you ever mess around with rotations, this is what it will spawn at. We can then get the rigid body 2D of the obstacle, which we're going to set to spawned obstacle.getComponent rigid body 2D. We then want to set the obstacle rigid body dot velocity equal to a new vector2 dot left times, and then we want some sort of speed variable here, so we're just going to create a public float called obstacle speed, and we'll set this zone to like 1f to start with, and you can mess around with this value later. Now this will basically just tell it to keep going left. So let's give this a try and see what happens. So let's go back to our game, our Unity instance. Let's wait for the spawner script to compile. Then all we want to do is select each one of our prefabs. So what we can do is we can lock this up here so the inspector doesn't change. Then we can select each one of our prefabs and drop them into our prefab list. And then what we can do is just essentially hit play and see what happens. So you can see obstacles are being spawned, and although they are extremely close to each other, so we're going to have to play around with the speed and the times. This, as you can see, is spawning obstacles. Now we're kind of stood on the wrong obstacle. Anyway, so you can see that. So let's make the obstacle spawn timer 3 and the obstacle speed also equal to 3. This will make them much more distanted. This will make sure they're a lot more far apart before it spawns the next obstacle. And you might want to play with these times to get something you like. Here we go. We have our first obstacle. We can just jump straight over, although we did just hit that. We can duck under this one and duck under this one. And there you go. You can see it just keeps getting spawning different objects depending on what there is. Though we die on that one. I'm not even sure if this one is possible currently. No, it looks like we die every single time. So we may need to mess around with this again. I actually suggest upping the speeds. That should make it so it actually spawns them quicker and we can jump over them quicker. So the next thing we want to do is we actually want to go back to our players, unlock the inspector so you can actually see it move, and let's add a player collision script, which will deal with all the collisions that happen with the player. We're just going to reset its transform for now, and then inside of here we're going to create a 2D sprite triangle. You can add your own sprites here, whatever you want, but I'm going to just stick with a simple triangle, which will just be our spike, and we'll make this some sort of red color. That'll do for now. We can tweak all of the colors and stuff later on. Then I want to get our obstacle and actually place in, let's say, a small triangle, because what we want to do is we want to align our inner triangle with this. So what I'm going to do is I'm just going to bring this up here. I think this is fine. This will make it so if we put this let's say -4 or -3. Oh, that's the wrong one saying that. The spike at -4, you'll see it actually sits pretty flush with the ground. Obviously, it's slightly overlapping, but that's good. That means we won't see any textures. And this will be coming in like this, like as you're moving, this is coming towards you. And what we want to do is we want to make sure all our obstacles, the base of them, will always sit in line with these ones, meaning we can spawn the obstacles. And let's say we wanted a spike slightly up, we could actually have it up here. So obviously it won't be a spike, it'd probably be a bullet or something like that. But it could be up here, and that way the origin is what we'll move. left and right, and it'll keep the element where we want it on the screen. So with this, what we want to do is add in a polygon collider 2D to our triangle, just to give us that spike shape for our actual collider. We then want to go to the spike obstacle, and we're going to add a rigid body 2D that's going to be set to kinematic. This is just because we don't need to move it other than inside of a script. We're also going to freeze its rotation because the spikes don't need to rotate, and same with its Y because it will not be moving up and down, just left and right. We'll also set collision detection to continuous. Finally, we want to create a new tag called obstacle, and then once you've got a new tag called obstacle, come back to the spikes and apply the obstacle tag to both your elements.